You opened an incognito window. You thought that meant something. It does not mean what you think it means. Right now, across millions of browsers, people are opening private tabs, believing they have disappeared from the internet. They have not disappeared. They have just cleaned their bedroom while leaving the front door wide open. The window is private from your own device. From the outside world, you are just as visible as before. Sometimes more visible because of how you behave differently in private mode. And the websites you visit have known this for years, not suspected it. Known it, documented it, and in many cases built detection systems specifically to catch it. This is not a conspiracy. It is engineering. The gap between what Incognito promises and what it actually delivers is one of the most consequential misunderstandings in the history of consumer technology. And the people who built these browsers wrote the answer in plain English in the same window you opened to go private. Almost nobody read it. If you enjoy understanding how systems actually work under the surface, subscribe. It is the best way to support this work. Drop in the comments what country you are watching from. Now back to it. Here is what Incognito actually does. It stops your own browser from saving your history, your cookies, and your form data to your local device. That is the complete list. That is everything it does. When you close the window, the local traces disappear. That is the product. That is what was built. It was designed as a privacy tool for shared computers, for the person borrowing a friend's laptop who does not want their search history sitting there afterward. It was never architected as anonymity software. The Chrome team shipped the feature in 2008. The disclaimer in the opening screen of Incognito has always said, explicitly, that your activity may still be visible to websites you visit, your employer or school, and your internet service provider. The words have always been there. The assumption that it meant something more powerful persisted anyway. Your IP address does not change when you go incognito. Read that again. Your IP address, the numerical label assigned to your internet connection by your internet service provider, and the address that identifies your physical location to within a neighborhood, the thing that every server you contact logs by default, does not change at all. Opening an incognito window has zero effect on your IP address. A website receiving your request in incognito mode receives the same IP address it would receive in a normal tab. If they were logging it before, they are logging it now. That alone should end the conversation. But it does not, because IP matching is just the beginning. Browser fingerprinting is the mechanism that makes incognito detection reliable at scale, and most people have never heard of it. Here is what it does in plain English. Every browser, on every device, behaves in slightly different ways. The combination of those differences is unique enough to identify you, the same way a fingerprint identifies a person, even with no cookies, even with no login, even with no history. The fingerprint is assembled from the data your browser broadcasts automatically every time it contacts a server. Here's why this is insane. You did not consent to broadcasting this information. You did not install anything. You did not click agree on a special terms page. Every browser on Earth does this automatically as part of how web protocols function. The data is not hidden. It is sent as part of the standard connection process. But the combination of signals is specific enough to track you across sessions, across sites, and across incognito windows with accuracy that researchers at places like the Electronic Frontier Foundation have documented in published studies. Think of it like this. Imagine you walk into a store wearing a disguise, new hat, sunglasses, different jacket, but you have a very specific walk, a very specific height. You always scratch your right ear when you stop. You always hesitate at the same display. The store's cameras do not need to see your face. They already know it is you from the combination of a dozen smaller signals that you never thought to change, because you did not know anyone was watching them. That is browser fingerprinting. The technical term for the composite identifier assembled from these signals is a browser fingerprint. The measurement of how unique a given fingerprint is has been studied formally. A project called Panopticlick, run by the Electronic Frontier Foundation, found that in a sample of hundreds of thousands of browsers, over 90% had a fingerprint that was unique within the sample. One signal alone is not enough. The combination is what makes it specific. What signals go into the fingerprint? Your operating system and its version, your browser type and version, the screen resolution of your monitor, the time zone your device is set to, the list of fonts installed on your system, the graphics card your device uses to render images, captured through a technique called canvas fingerprinting, where the server asks your browser to draw a hidden image and reads the tiny rendering variations that different hardware produces, the list of browser plugins you have installed, your language settings, whether your browser accepts cookies at all and how it handles them, the way your browser responds to certain JavaScript commands. None of these signals individually is secret. All of them together form something that is, statistically, as unique as a name. And incognito mode changes almost none of them. Your screen resolution does not change. Your fonts do not change. Your graphics card does not change. Your time zone does not change. Your operating system does not change. You open an incognito window and present what is functionally the same fingerprint to every server you contact. The disguise was the browser. The fingerprint is the hardware and the configuration underneath it. Now here is the part that gets more specific to detection. There are behaviors that are statistically different in incognito mode compared to regular browsing. Researchers and engineering teams at major platforms have documented this. Incognito users, on average, block more by default. The browser sends slightly different headers. Certain API calls, application programming, interface calls, the small requests browsers make to gather device information, return different values in private mode. Google's Chrome browser restricts access to the file system API in incognito mode as part of its privacy implementation. That restriction is detectable. A site can make a call to that API, observe the result, and draw an inference from the failure. For years before Google patched it in Chrome version 76 in 2019, this was a reliable and widely documented method for detecting incognito mode with near certainty. The patch changed the behavior from a hard failure to a limited quota, meaning developers adapted their detection logic and moved on. Safari's private mode has had similar detectable differences in how it handles storage quotas and certain JavaScript behaviors. The cat and mouse game between privacy features and detection methods is ongoing. Every time a browser closes one detection vector, developers find another, not because they are malicious actors, because the underlying signals are structural. They emerge from the way privacy restrictions interact with web APIs, and those interactions produce measurable differences. The scale of this is worth stopping on. According to data published by StatCounter, Google Chrome holds roughly 65% of the global browser market as of recent years. That means the majority of every private browsing session happening on Earth at this moment is running through a browser made by the same company that operates the largest advertising network on the planet. Google's stated policy is that it does not use incognito browsing data for ad targeting. In 2024, Google settled a class action lawsuit in the United States for $5 billion that had accused the company of tracking users in incognito mode without adequate disclosure. The settlement did not include an admission of wrongdoing. It did include a requirement to delete billions of data records collected from incognito sessions. The lawsuit was filed in the Northern District of California. The plaintiffs alleged that Google collected data through Google Analytics, Google Ad Manager, and other tools embedded in third-party websites. Tools that operate regardless of whether the user is in incognito mode, because those tools are on the website's server, not in the browser. The browser's private mode cannot stop a tool that runs on the destination server from logging the visit. This is the part that most people miss. Incognito blocks your browser from recording data on your device. It does not block the destination website from recording data on their servers. These are two completely different things. One is local, one is remote. The private mode only controls the local side. Every analytics tool, every tracking pixel, every embedded third-party script running on a website you visit in incognito mode receives your visit the same way it would in a normal tab. Google Analytics, which is installed on an estimated 30 to 40% of all websites on the internet, according to data from W3Techs, logs page visits by IP address and by browser fingerprint signals. A visit in incognito mode is a visit in the log. It is not labeled differently. It is not excluded. The advertising infrastructure compounds this. A retargeting ad, the kind that follows you across the internet after you visit a product page, works through a combination of IP matching, probabilistic fingerprinting, and in some cases, cross-device tracking. You browse a product in incognito, then close the window. Later on your phone or in a normal browser session, you see an ad for that exact product. You wonder how that happened. The answer is probabilistic identity resolution, the technical term for systems that match your behavior across sessions using signals that survive the incognito window, most commonly your IP address, your device fingerprint, or both. Some platforms go further. Login state is one of the most powerful identity signals available, and it bypasses fingerprinting entirely. If you are logged into any Google service in a regular tab, Gmail, YouTube, Google Docs, and you open an incognito window, you are starting a new session with no cookies. But the moment you log into any Google service inside the incognito window, the anonymity is over. The account connects the session to your identity. Facebook operates the same way. Amazon operates the same way. Any platform that asks you to log in and tracks behavior across sessions will associate your incognito activity with your account the moment you authenticate, and in many cases, through probabilistic matching even before you do. Your internet service provider sees everything regardless. Incognito mode has zero effect on your ISP's view of your traffic. They see the domains you contact, the volume of data you transfer, and the timing of your sessions. If you are not using a VPN, an encrypted DNS, and most people are not, Your ISP can see every domain you visit in an incognito window in real time. The traffic is not encrypted from their perspective, simply because the browser is in private mode. Encryption is a separate layer. Incognito mode does not provide it. Workplace networks add another layer. If you open Incognito on a work computer connected to a corporate network, your employer's network monitoring tools see your traffic the same way your ISP does. The Incognito window prevents your history from saving locally to the machine. The network logs on the server side are unaffected. IT departments at large organizations routinely use network monitoring software, products like Cisco Umbrella, Zscaler, and similar enterprise tools that log domain requests at the network level, not the browser level. Private mode is invisible to these systems. They do not interact with the browser at all. Here is something even sharper. The behavioral profile of someone using incognito mode is, in certain contexts, more valuable to advertisers than a normal browsing session, not less. The logic is counterintuitive. A user in incognito mode is, statistically, engaging in behavior they consider more private. Research published in peer-reviewed marketing and behavioral science literature has explored the inference that high-privacy browsing sessions are correlated with higher purchase intent for certain product categories. The things people look up in private mode are often the things they are more seriously considering. An anonymous session tied to a sensitive search, matched back to an identity through IP and fingerprint, represents a high-intent signal. The privacy of the act does not protect the act from observation. It signals motivation. This is where the architecture becomes important to understand as a practical reality. There's exactly one tool that actually addresses the IP address problem. A VPN, a virtual private network, which routes your traffic through a server in another location and presents that server's IP address to the destination website instead of yours. Even VPNs are not total solutions. The VPN provider itself sees your traffic. The fingerprint problem is unresolved, and login state collapses anonymity the moment you authenticate anywhere. But a VPN at least addresses the IP layer, which Incognito does not touch at all. The Tor browser, built on Firefox, maintained by the Tor project, a nonprofit, routes traffic through multiple encrypted relays, changes your apparent IP address with each session, and standardizes browser characteristics to reduce fingerprint uniqueness. It is the closest thing to genuine anonymization that exists in consumer software. It is also slow, and it cannot be a substitute for understanding what the underlying problem is. The practical reality for the vast majority of users is this. If your concern is that someone sharing your device sees your history, Incognito solves your problem completely. That is the use case it was built for. If your concern is that websites, advertisers, your employer, or your ISP cannot observe your behavior, Incognito does not help you. It was never built for that. The gap is not a flaw. It is a design scope mismatch that became a cultural misunderstanding. The feature shipped. The name was sticky, private, incognito. The words implied something the technology did not do. Nobody issued a correction at scale. The misconception spread, and the infrastructure on the other side of the screen continued logging every visit, assembling every fingerprint, and resolving every identity, in private mode and outside it, without interruption. Here's the rule that changes everything going forward. Before you open an incognito window, ask one question. Am I trying to hide this from my device or from the internet? If the answer is your device, your browser history, your autofill, your locally stored cookies, Incognito works. Use it. If the answer is the internet, the website, the advertiser, the employer, the ISP, Incognito is doing nothing for you. The tool you need is different. And knowing the difference is the thing that the name was designed, whether intentionally or not, to obscure. Here is the fact that lands last. When Google settled that $5 billion lawsuit over incognito tracking in 2024, part of the agreement required Google to update the description shown to users when they open an incognito window, the screen that explains what private mode does and does not do, the screen that has always been there, the screen almost nobody reads. The information was always in the room.